Hello everyone, welcome to Network Theory special series. This is Naveen Kollapalli. Welcome to everyone. Hello Manoj, Manu, hi. Good evening, very good evening. Manoj Kumar, hello. And how are you all? Hello everyone, how are you? What about the homework question? Have you done that? How much the answer you got for that one? And I have given one dependent source. I asked you to calculate Thevenin's resistance. Only one dependent source is there. Voltage controlled current source is there. Okay. Abdul, very good evening. Hello, how are you? How are you doing? Shri, good evening. And Matthew, good evening. Varsha Jyoti, good evening. A very good evening to one and all. How are you all? Slowly joining one by one. Ganesh, very good evening. Rajkumar, how are you? Hello. Chalo. Uh, let's see slowly. We'll get into the homework question. Anybody got the answer? You can say post the answer. How much you got the answer for that one? The previous question which I have given to you, that is dependent source one. Hmm? Adesh Singh, good evening. Shweta, hello. How are you all? Vishnuvardhan Raju. Not exactly Vishnuvardhan Raju. Not entire network theory. ये तो trailer है. So the complete full course will be available on paid courses. Good evening, Pratibha, and good evening, Rizvi. Rajkumar, hello. All right, let me get into the homework question. Before getting into the homework question, I just want to tell you about the today's session. Of course, the previous session and today's session is going to have transients and the previous theorems part. Okay, maximum power transfer theorem one question and the reciprocity and reciprocity theorem one question. Okay, before taking the questions, I just want to tell you about our courses, that is Vision 2021 batch 3 which is going on, and you will be having 50% discount if you are gate qualified and or if you are from IIT and IT, or if you are prelims qualified. If you have any doubts, you can contact here, and you can mail also for this mail ID or this mail ID. They'll reach you out and they'll help you out. And coming to another course, that is SSC JE, and especially for EEE electrical engineering students, and here also you'll be getting 40% discount if you are from government engineering college and if you are already qualified in paper 1. Still, if you have any doubts regarding this, and if you want to have more information, if you want to get more information, you can mail or you can contact even given number. Okay, now if you got the answer for yesterday's question, please post it. I'll read out your names also. That will be better. Guru Lakshmi Pala, good evening. And Rahul, good evening. Rahul, subject wise course नहीं है. तो आप क्या पूछ रहे हैं? आप क्या जानते हो, क्या जानना चाहते हो? मुझे समझ नहीं आ रहा. Okay, anyhow, Ajesh, good evening. Let me get into the homework problem so that we can move on and I can take the comments in between. This is what the question which I have given in the last session, and the answer. How many of you got the answer for this one? Anybody did this one? Nobody. You didn't dare to do this one, huh? Are you running out of these problems, or you're not able to face these problems? I don't know what. Are you facing any difficulty in solving this kind of problems, dependent source problems? Please stay tuned to this Gradeup channel. You'll not face any difficulty because so many videos are available. No, you can do it, no issues. Okay, let me go ahead with this one. As the network consists only passive elements and dependent sources, definitely it doesn't have any element which can deliver. It doesn't have any active element, so it cannot deliver any energy, and hence the network is not active. If the network is not active, VTH is completely zero. So here VTH is going to be 0. Now you need to calculate only RTH. How do you calculate RTH? by connecting a voltage source across open circuit terminals, known voltage source. That is, I am assuming it as V. I am assuming it as V and it is going to deliver a current I. Alright. I said in the last session you can convert this current controlled, voltage controlled current source and 200 ohms resistance into a voltage source so that you can reduce the network and you can get like this minus plus, anyhow, voltage source we are going to do no. So 0.1 V1 into 200, it comes out as 20 V1 and in series with 200 ohms resistance, and the 200 ohms resistance will be in series with 50, so you'll be getting it as 250 ohms, and later this branch is going to be 100 ohms. Across that 100 ohms, V1 is the parameter, controlled parameter for the dependent source. I already said in the last session, once again I'm repeating that if the V1 is given across 200 ohms, don't dare to convert into voltage source. If you do so, you will be penalized a lot. A lot means a lot. Okay, then you can do this one. Apply KVL through the outer loop, you can get it. So if I current is delivered by voltage source, that I current is entering at this principal node, what is the current flowing through this branch, sir? What is the voltage across this 100 ohms? V1. V1 voltage across this 100 ohms is V1. Is it not equals to V? Why? Because V voltage source is connected directly across 100 ohms. So I can call wherever V is there, you can replace with V1, or wherever V1 is there, you can replace with V. So I can say that this is V, and I can even write it this as 20 V. Alright, now the voltage across this 100 ohms, I am saying it as V, that is equals to V1. So what will be the current now? The current will be V by 100, voltage divided by resistance. If I is coming towards a node and V by 100 is leaving from the node, remaining current leaving from this node will be I minus V by 100. Is it not? Apply traffic jam rule, sir. If 3 roads are there connected to a common junction, 5 buses are 5 buses are moving on one path. Okay, and entering at one node. 3 buses are leaving from that node to another road. Remaining 2 buses will leave another node or not? If that is so, okay, try to understand. Okay, so I know the current and I can even find out the polarities here, and you can write KVL through outer loop. If you write KVL through outer loop, then you will get the KVL equation. Try to get the KVL equation in terms of V and I, capital V and capital I, so that you can calculate in single step RTH. So I am moving from this point to this point. I am leaving with positive polarity, so plus V. And now this point to this point, I am leaving with negative polarity, 250. 250 is the resistance and current will be I minus V by 100. Next, this point to this point. What is that polarity I am leaving? Plus. How much voltage? 20 V. Is that any another thing here? Nothing. So equals to 0. Chalo, take up V terms. If you take V terms as common, you will get it as 1 here, and this will be plus 250 by 100. If it is plus 250 by 100, I think so it will be 2.5 V and plus 20. Is it so? Correct me if I am doing anything wrong, if I miss any polarities. Plus V and minus 250 into current I minus V by 100 and plus 20 V. Leaving polarities, all leaving polarities I have considered. Okay, so this will be plus 250 by 100, 2.5, and plus 20 is equals to 250 I. Alright, this will be 23.5 up. V by I is equals to 250 divided by 23.5. How much is the answer you are going to get? How much is the answer you are going to get? Did anybody got that one? 250 divided by 23.5. 10.63. Apply nodal. You can write nodal. You can write KVL through outer loop if you know current. Rahul. Umesh, tell me answer. Umesh, 25 ohms will be the RTH, not exactly 25 ohms. I'm getting less than 25, 10.63 around. Is it so? Did everybody got that answer? 10.63 ohms is the answer. Did everybody got the answer? 10.7. Very good, Rahul Maurya. Somebody got Anjan Banerjee. Very good, Anjan. From Kolkata se kya? Looks like Banerjee from, yes, 10.64 Anu, and Saujanya 10.63, Uppaluri Karnakar 10.6, Uppaluri Karnakar. Very good, excellent. So Rajkumar even said, Guruji, Koneji, Ashish Chaudhary, Namaskar. Kaise ho? Very good. And any other? Missing your chart. Okay. Rakesh, very good. Did I write Om or Mo? Ohms only. Did I say volts? Ohms and volts sounds same like. Manoj, very good, 10.6. Rizvi, volts, when I speak volts and ohms, sounds same, I think so. That might be the problem you are facing, am I right? Okay, chalo. Do you have any doubts here? Do you have any doubts here so that we can move? If not, we can move to. If not, we can move to another one. If not, we can move to another one. All right, no doubts from Kolkata, Banerjee. Chalo. All right. So have you calculated this VTH and RTH? Yesterday in the last session, we calculated this VTH and RTH. How much we got? VTH and RTH. VTH we got -5. So I am writing polarities downward direction. So VTH is 5 volts, -5, and RTH also 5 ohms. And your RL must be 5 ohms. If it is so, what is the current? 5 by 10.5. Is it so? 0.5. Now your maximum power will be 0.5 whole square divided. So for 0.5 whole square into 5. 0.25 into 5. Alright. So that could be the answer. 1 by 4. 1 by 2 whole square is 1 by 4. 5 by 4 watts. Did you get this one? I think you got this one. 2-port network. Yes, I'll do 2-port network at the end. I have mentioned no 2-port networks, Manoj. We'll do that one. Umesh, what no? What no? You're saying no about what? So this was I didn't do about maximum power. Did you got everybody? And I'm moving to the next question. Very good, Rahul. 5 by 4. Right, 1.25. Very good. Amay, very good. Uppaluri Karnakar, very good. Yes. Done. I think you don't have any problem with that one anyhow. We did in the last session. Chalo, see this one. We'll move to this question. See this one. Try to observe this one, sir. This is a very familiar question you are going to get, especially in PSUs and engineering services, sir. In GATE, very rare, hardly in 30 years of history, hardly twice or once are asked. But engineering services, if not triple E, it might be in EC. If not EC, it will be in instrumentation. Okay. If that is missed in prelims, you may get a chance to appear in conventional also for part A questions. 1 mark or 2 marks questions are there. No, that kind of question. There is a chance. There is a possibility. So what is the question? What is the question? He is asking the value of R for which the power dissipation is maximum. The value of R. This is R for which the power dissipation is maximum. Maximum at what point? At load point, sir. Be careful, that is missed. Okay. So, what value of resistance should be placed in the R variable value to get maximum power dissipation across this 5 ohms resistance or this RL, sir? RL, I am writing here. Okay. You might be knowing, sir. It is like this, sir. Here I have a source. I have a sink. Sink is nothing but load. So, source is to deliver the energy maybe via transmission lines or via the connected lines. All right. When the load can get more power or more voltage or more current, if the medium which is connected between source and load, source and sink, is a less resistive path, is a less opposing path. Sir, no? Sir, no. Source is here, sink is here. Between the source and sink, I need to connect them. So the connecting wire should possess low resistance so that maximum voltage will appear. Why? Because minimum voltage drop takes place in the leads, and hence maximum voltage will appear. Therefore, maximum power consumption will be taken place. That is a simple logic, sir. That is a simple logic. This is not this model is not same as the previous model. Okay, the previous model is RLV. RL is variable. Here RL is fixed. Here RL is fixed. When RL is fixed, when load resistance is fixed, you have to adjust the medium resistance. You have to adjust the medium resistance. You simply take an example, sir. आपके घर में lamps रहेगा, incandescent lamps और fans रहेगा. Whenever you get less voltage, कम voltage कम आया तो क्या करना पड़ेगा? आप कुछ कर सकते हैं क्या घर में? हाँ, कैपेसिटर लगाए तो और कुछ लगाए तो ये वोल्टेज इंप्रूव होता है क्या? आपसे कुछ भी नहीं होता. कौन कर सकते हैं वो सब? इलेक्ट्रिसिटी डिपार्टमेंट वाला कर सकते हैं. आप कहां पर करना? ट्रांसफार्मर सेकेंडरी पे जाके आप टैप चेंजर चेंज कर लो तो वोल्टेज बढ़ जाएगा. वोल्टेज बढ़ जाए तो आपको वोल्टेज बढ़ेगा. तो इसका वजह से your voltage across the lamp, voltage across the electrical devices will be increased, and hence what happens? The current flow will be increased. Therefore, the heat dissipation increases in the incandescent lamp, and your light glow also increases. If the voltage is less, current is less. If the current is less, heat dissipation also less. If heat dissipation is less, brightness is also less. How heat dissipation results in brightness? Incandescent lamp में क्या होता? argon neon gases होता ना. तो heat while heat is dissipating, it will collide with the argon neon gas molecules, and it will radiate, or it will convert into a light form. Alright, the same logic here also. Whatever the medium which is connected between source and sink should have minimum resistance. Should have minimum resistance. You might be aware of this question, but try to think in the practical format. You just take a transformer and take your house. If your home is suffering from low voltage, what you have to do? Will you do anything at your circuit breaker? You cannot do anything. Go to transformer, change the tap changer. Increase the tap changer, increase the voltage level, then you will get more voltage, sufficient voltage, so that you will get good voltage and you can have good power consumption. That is what I'm trying to say. So what should be the value of this resistance? If you keep 0 ohms, observe what is the power. If you put 6 ohms, observe what is the power. Okay, I'm going with 0 ohms. If R is equals to 0 ohms, what is the equivalent resistance, sir? Here, sir. What is the equivalent resistance, sir? 0 and 6 are in parallel. 0 and 6 are in parallel. So it will be 0. So the equivalent resistance will be 0 ohms in that path. So it will be 0 ohms and 15, and आपका लोड का रेसिस्टेंस होगा 5. वो तो given है. So directly 15 volts is appeared across this load or not? Directly 15 volts is appeared. If there is a resistance, voltage drop will take place or not? Voltage available across load will be reduces, and power consumption also reduces. Maximum power, the power value also reduces. So what is the power here? V square by R, simply 15 square divided by 5. That is your answer. If you take 6, if R is equals to 6 ohms, what will be the equivalent resistance? 6 and 6 are in parallel, so you will be getting it as 3 ohms. If it is 3 ohms, then 15, and यहाँ पर आएगा आपका load resistance 5. तो how much here it is? 3 plus 5, 15. So what is your I आएगा? Otherwise you can even do voltage division also, no issues. So the maximum power PL is equals to 15 by 18 whole square, that is 5 plus 3. Sorry, 5 plus 3 is 8 only, no? Control E. Right. 15 by 8 I square into 5. You can do what is this value and check this value. As the resistance is changing from 0 to some other value, your power consumption by the load decreases. That is what the conclusion you have to get. The medium resistance should be as minimum as possible in order to reach maximum power towards the load. Alright. Did everybody got that one? I know 0, 0, 0, 0. AG, you are saying 0. You are saying short circuit. Yes, exactly, short circuit. Very good. If 0 is not the answer, if 0 is not the option in your question, Monica 0, very good. Nitesh, very good, 0. And some other persons also. Saujanya, okay, for that previous one. Okay. If 0 is not the one, if 0 is not the option available in out of 4 ABC, 4 options given to you, what could be the best possible, sir? What could be the best possible option for you if 0 is not there? Hmm? What could be the best possible option? Anybody? Can anybody tell me the answer? If 0 is not given to you. Very good, Monica. Excellent. Very good, Nitesh. Very good, Abdul. Hmm. Choose the minimum value. Choose the minimum value. If 0 is not included, then choose minimum resistance. Very good, Rajkumar. Very good. Excellent, everybody. Preeti, very good. All right. Oh, Manoj Kumar. It's not 6, man. You should not choose 6. You should choose minimum resistance. You should choose minimum resistance. And be careful. That should lead this R and this 6 ohms should lead a least value. Okay, least value and check. Okay, conditions apply. Huh? Choose the minimum value in the given options. Obviously, they'll give you. According to that one, you can select. Okay, minimum value is the best option. Okay, let us move to another question here. Let us move to another question here. Very good, Shreya. Least value of R. Very good. Have you seen this question any time? I think you might saw this in engineering services prelims most of the times and the civil service examinations also. This kind of questions are asked multiple times. In GATE, very rare. I think so, very rare. When it comes to ESE, it will be very frequent question. This kind of questions. Block box will be given. Block box. Nothing is visible, and they'll give you some information. From that information, you have to understand the data and you have to calculate what actually they want. Try to do this one, sir. If you are aware of this one, try to do it. Okay. What is asking? I'm going through the question. What is asking? If E is equals to 15 volts and I is replaced by a resistance R equal to 5 ohms, then what is V? E is given here, V is given here, I is given here. And some data also given. E 1 volt. When E is equals to 1 volt, this is not 1, sir. This is I. When E is equal to 1 volt, I is equal to 0 ampere. V is equals to 3 volts. And when E is equals to 0 volts, I is equal to 2 amperes. And V is equals to 2 volts. That is the data which is given. Okay. Use that data which is given in the basket and try to do it. Chalo. According to the given data, I am drawing the circuit, sir. So this is my E. And that E value is 1 volt. Alright, this is my network N. What he is saying, I is equal to 0 ampere. 0 ampere is nothing but what? Current is not flowing. Where current will not flow? Potential difference is equals to 0. When potential difference equals to 0 or when the circuit is open. Be careful. Current will be 0 means open circuit. Most of the people will say open circuit. Of course, open circuit. Sometimes if the potential difference across this point and this point is same, potential difference is 0, current will not flow. So here 0 amperes. I am replacing I with the open circuit. Okay. Here open circuit. I is equals to 0 amperes. Now what he is saying, V at that time V is equals to 3 volts across this terminals. V is given across these terminals only. No. So V is equals to how much? 3 volts he has given. 3 volts he has given. That is the first information. Next information. E is equals to 0. Chalo, short that one and draw the network. E is equals to 0. Now what is I? I is saying that 2 amperes. Now this current source value is 2 amperes. What at that time the voltage appeared across these terminals is 2 volts. All right. From this data, you can understand one thing. From this data, you can understand one thing, that whenever the network is excited with 1 volts voltage and the other side, if it is open circuited, the open circuit voltage is 3 volts. Can I call this open circuit voltage as Thevenin's voltage? Yes or no? Open circuit, the voltage across any open circuit terminals in a circuit is called as Thevenin's voltage. Okay. Similarly, from this side, from the second figure, the entire network, as the voltage source is replaced by short circuit and the entire network is connected by a known current source, at that time, it is drawing 2 amperes current. It is drawing 2 amperes current, and across that network, 2 volts voltage drop is created. That means what? Is it not like a voltage and current information, and can't you say R is equals to the entire network resistance can be taken as simply 2 volts divided by 2 amperes. You can get it as 1 ohm. The network is capable of the network is capable to oppose, or the network is capable to have a resistance of 1 ohm. At that 1 ohm, it is taking 2 amperes and dropping a voltage of 2 volts across the terminals, right? So that whatever the block box given to you can be replaced with Thevenin's voltage and Thevenin's resistance. So then I am drawing here whatever the block box here, Thevenin's voltage, that is 3 volts, and Thevenin's resistance 1 ohm. Now these are my terminals. Okay, from these two. Sir, be careful, sir. Here I am calculating RTH. Here itself I am calculating VTH. Be careful. You should calculate RTH and VTH at the same point, sir. Okay. Right. Now what is saying in the question? If E is equals to 15 volts and I is replaced by resistance 5 ohms. If at this terminal current source is not connected, now it is connected as a resistance is connected. Now what could be the value of V is asking. Most of the people will commit a mistake here itself. Did everybody getting this one? Please try to understand this one. Are you getting everybody? Are you getting this one? Are you getting Rahul and Shreya, Matthew? Are you getting this one? Most of you, I can't read out your names. I'm reading just your names which appeared in the last. See this one. I have got the equivalent network. I have got the equivalent network which is I have got the equivalent network of block which is given to you, and I am connecting a 5 ohms resistance at the current source. Now, now will you calculate V? Will you calculate V? What is the value of V? What is the value of V? Most of the people will do the mistake here itself. You are getting 2.5? Rahul, Chaitanya, hi. 2.5. Is it so? 2.5? Everybody is getting that one? Please try to 2.5 may not be the answer. Everybody. 2.5. Rajesh, 2.5. The question itself makes confusing. Is it? Elango? Hi, Elango. Where are you from, Elango? But is that surname or is that... it sounds good. Neeraj Yadav, 2.5. See, sir. Okay. Chalo. Try to understand this one. See, this is according to whatever in the dabba information is there, no? That dabba I have written here, figure 1. Okay. And figure 2, this dabba information, figure 2 here, this one. Now, उसमें से मैं RTH निकाला और फिगर 1 से VTH निकाला. जो ब्लॉक बॉक्स है नेटवर्क का, ये सब नेटवर्क का इक्विवेलेंट नेटवर्क है ये. ऑल राइट. नाउ ये टर्मिनल के then across these two terminals, then I have connected whatever the given resistor. Now, is it possible to get the voltage? At this point, most of the people commit a mistake. See now, how it is going to be. See, be careful, sir. Try to understand this one. When E is given to you, that is when E is given as 1 volt, what is the open circuit voltage? 3 volts. But if E is not 1 volt, now E is not 1 volt, now the E is 15 volts. That means what? This is not 1, this is 15. How many times the voltage is increased? 15 times the voltage increased. According to homogeneity principle, any linear network which is excited or which is any linear network, if the source value is increased by some k times, the response is also increased by same k times. That is what homogeneity principles, right? So as voltage is increased by 15 times, your output also, response also increased by 15 times. That is 15 threes. How much are you are going to get? 45 volts. Now the V Thevenin is not 3 volts, is increased by 15 times. You are going to get 45. All right. Now 45 you should take up with 45, sir. Be careful. 45 volts. Are you getting me? If you understood, tell me. If not, I'll explain once again. Now you can calculate voltage across this 5 ohms. So voltage across that 5 ohms is equals to 45 into 5 divided by 6. That could be the possible answer. It could be around 37, 38 around, like that. Are you getting? Chaitanya, Vepula, Velpula, very good, excellent. Manoj Kumar, Anantapur, Anantapur Jagrata. AG 37.5, very good. 37.5, Monica, Saujanya, Vatepalli. Did you get that homogeneity principle, everybody? Homogeneity principle, Ajesh, understood? Very good, thank you. If you got homogeneity principle, then fine, sir. Okay, if you do not get homogeneity principle into your mind, you can't. Nobody can help out, sir. Nobody can help out you. Okay, is that clear for everyone? Tara, Matthew, very good. 37.5. Is that clear for everyone? If so, we'll move. Once again, you want Pratibha. Pratibha, where you want me to explain once again? Once again means the entire question. Abdul, clear. Pratibha, Joseph. How can I say, my dear? Anu, Vasam Setti, 37.5. Did you get that homogeneity principle? Somebody asked me, Pratibha, you didn't understand homogeneity principle? If you don't understand, please see here. I am drawing once again for you. See, the equivalent network for the given block diagram, I have got it as 1 ohm Thevenin's resistance and 3 volts as Thevenin's voltage. All right. Now, this is the voltage. This is the 3 volts is the voltage which I have got. That 3 volts is the voltage which I have got when the E value is 1 volt. All right. This 3 volts is the voltage when E is equals to 1 volt. But is he asking the value across resistance under E is equal to 1 volt? No. He has given E as 15. No. So as he has given E as 15, I am increasing. If E is 15 volts, this open circuit voltage also could be increased by 15 times, right? According to homogeneity principle. If you remember homogeneity principle, then you can understand this one. All right. So as E is increased by 15 times, this VTH also increases by 15 times. That is why you will be getting 45 volts. VTH has Thevenin's voltage as 45 volts. That is a reason, Pratibha, so that you can get it. Pratibha. Last step. Which one? Voltage division? Oh my goodness. This one. If it is so, simply this one, sir. Voltage across this 5 ohms resistance, no? Source voltage into voltage across 5 ohms. Source voltage into R. Total voltage divided by total resistance. That is 5 plus 1. 6. 45 by 6. You will get current. This is I. 45 by 6 is the current I. And I into resistance. The same thing I have written here. Okay. There's not much difference. You might be writing I into R, but I have written here Vs into something. Okay, if that is cleared, please we can move forward. Yes, AG. All right, we'll move to the dangerous part of the networks. Are you ready to face transients? I have a story for you. Tomorrow I'll take up that one. Actually, there is a small test experimental you can do at your home also, if possible. If possible, you can do. Chalo, we'll move on to this one now. All right, let me give you some a small example or a small story about transient. What do you mean by transient? Transient and a transition, both are same, sir. Transition is nothing but moving from one place to another place, or one level to another level. That's it. One state to another state. Transition, transient, all are same. Okay. Some people say that it's a sudden changes. That is also okay. No issues at all. Now the question is, who causes or who results in transients? For why do you get this kind of transients is a question. Why do you get this kind of transients is a question. Simply, if a network is designed with the memory element, so-called storage elements, memory elements are not also called as storage elements. How many elements are there in our network analysis? Only 5 elements are there. Voltage source, current source, resistance, inductance and capacitor. Out of these 5 elements, voltage is a battery. Alright. So just leave about the source elements. And speaking about passive elements. Okay. I'm speaking about non-source elements. Those are resistance, inductance and capacitance. Out of these three elements, two elements are memory elements, that is inductor and capacitor. So whenever the network consists inductor and capacitor, definitely there is a chance of opposition for the source voltage changes or source current changes, or the voltage changes or current changes you are going to impose on the circuit. Okay, if I have a resistance and inductor, maybe connected in parallel series. Now I am going to take up, or otherwise you might be a simple example. You might have observed in your home. Take a capacitor, and terminals, touch them. If anything charge is there, you will get a spark. If nothing is there, nothing you will not get. Now, after discharging, you just take that, separate the terminals and put in the socket, insert in the socket terminals. Okay, one terminal in phase, one terminal in neutral. Don't put the other terminal in earth. Okay, or don't put two terminals in one socket. One terminal in phase, one terminal in neutral. Then the moment you insert the capacitor, you will feel the rush of electrons. So many electrons, a lot of electrons will get into the capacitor because capacitor plate is discharged already. If the capacitor plate is discharged already, so many electrons will come into the capacitor plate and sit on the capacitor plate. That is what charging. That rush of electrons, you can also call it as transient current. Will you get that rush of electron after 1 second or 2 seconds? Not possible. Why? By the time the capacitor is fully charged or fully stores the charge carriers on the plates. Once the charges are stored, once the charges are stored on the plate, then the potential across the capacitor and the source voltage will be, potential difference will be zero. Capacitor potential and source potential will be equal. Potential difference is zero, and there is no rush in electron. Current is zero. Current is zero means no electron flow. That means what? The rush of electron is taking place for only 1 or 2 seconds. That short duration, we are calling it as transition of the currents from huge value to zero value. or zero value to huge value. Disconnect the capacitor and touch the terminals. What will happen? Huge electrons will come and collide at this point at the joint. You can feel the spark also. You can feel the spark also. Okay, if you want to experience it, you can touch to your fingers. Okay, you'll definitely experience that one. All right. So that is what you'll get a shock. You'll feel the rush of electrons only for a few seconds, hardly 2 seconds, not even 1 second also. Not even 1 second. Why? Because body resistance is more. So discharging time is very quick. Tau is equal to RC. R is more. So body resistance depends on body resistance and capacitor value. The discharging time period depends on anyhow. So you might be experiencing the rush of electrons for 1 or 2 seconds, and after that nothing. So huge electron flow and zero electron flow. That is what transition. Huge flow to zero flow. So transition is nothing but a sudden change in value. Maybe a voltage, maybe a current. Alright. Who is causing that one? If the network has inductor or capacitor. Be careful. Transients are because of inductor or capacitor. Maybe both. At least one storage element, storing element should be there. Either inductor or capacitor should be there. Both also possible. If only resistors are there, not possible. If only resistors are there, not possible. Okay. All right. We'll see anyhow. Actually, it's an experiment. You can see with the frog kick. The experiment is very good actually. Frog kick is the experiment. I'll give you the question tomorrow so that you can experience at your home also. But before taking that experiment, let me go ahead with this question so that we can close up the session today. Try to understand this one. It's a previous gate model and I have given in a different way. You can, if you have already done, I think if you have already practiced, then that is fine. Rahul, I think you might. Yes, very good, very good, very good. Very good, Rahul. How many of you did this one already? What about voltage drops? Dolly, you're asking about voltage drops. Okay. All right. I am moving to this question, then I'll take up the comments at the end. Okay, let me end up the session with this question. Please try to understand this one. Tomorrow we'll take up the experiment with the frog kick. Then you'll come to know what exactly it is. Transients. Try to understand this question. The switch is closed for a long time and it is opened at t is equals to 0. And now he is asking, determine IL of 0 plus, V of 0 plus and IL of t for t greater than 0. I am not going to derive any equation, sir. I am just giving you directly the formulas. He is saying that the switch is closed for a long time. Sir, please observe the switching state. Whenever you want to do the transient problem, please observe the switching state. From at what point it is closed or at what point it is opened. He is saying that the symbol is saying that this arrow direction is showing you or telling you that it is opened. At what time? T equal to 0. That means what? At 0 instant, at 0 seconds, if it is opened, if I assume that t equal to 0, at this point it is opened, sir. Switch is opened. Now when it is closed, long back it is closed. That is minus infinity time to 0 seconds. It is closed. Minus infinity time to 0 seconds. It is closed. That means what? For a long period, it is closed. The switch is closed. Now, if the switch is closed, what will happen? See. If the switch is closed, this resistance and this current source will be in contact with inductor and 20 ohms resistance or not. The inductor and 20 ohms resistance will be in connection with 15 ohms and 4 amperes network to this side, left side, to the left of the switch. So that means as the current source is connected from minus infinity to 0 seconds, that means for a long duration, if it is connected, what will happen? This current source is going to deliver the current. Now, where it will pass? Definitely through 15 ohms, through 2 henries and through 20 ohms. 20 ohms. Okay, but as the source is connected for a long time, the inductor is going to behave like a short circuit. I'll tell you the story tomorrow about this short circuit and all those things in the frog kick test. But for time being, you just understand, under steady state is nothing but long time. From minus infinity to 0 seconds, it is a long time. Okay, that is long time is a steady state. Long time results in, as a source is connected to the inductor for a long time, you can take it as steady state. In the steady state, inductor behaves as short circuit. Now, if the inductor is behaving short circuit, is there any current flow through 15 ohms? No current flow. This entire 4 amperes will flow through like this. Is there any current flow through this 20 ohms? No current flow. Now, entire 4 amperes will divert through inductor. That means what? Before opening the switch, the current through inductor is 4 amperes. This is what we call it as previous current or past current. Okay, IL of 0 minus equals to 4 amperes. Now, you might have studied that inductor will oppose a sudden change in currents. If it opposes a sudden change in currents, the moment when you open the switch, then now the network looks like this. Now, the network looks like this. 4 amperes, 15 ohms, and inductor. This side, 20 ohms. The moment I opened the switch, now there is no connection between 4 amperes current source and the other side. So, as the inductor is opposing the sudden changes in current, in order to oppose the sudden changes in currents, what it has to do? It should be open circuited. Why? Because if the inductor is going to be open circuited, is there any current flow? No current flow. That means what? It can maintain the previous value. If the inductor can open, virtually open circuit, okay, inductor opens means inductor will not disconnect from the circuit, sir. Virtually it is going to open. If the inductor can open, then it can maintain the previous value. So after opening the switch at t equal to 0, just after the switch opening, that is t equal to 0 plus, now the current through the inductor, again it is 4 amperes. IL of 0 plus. Why? Inductor opposes sudden change in currents. So if the current through inductor is 4 amperes, the same enters here and leaves here and flows like this. The current flowing through 20 ohms is 4 amperes and comes back and flows through inductor. Is there any current flow towards this one? Yes. How much that one? 4 amperes through 15 ohms resistance. There is no connection between switch right side part and left side part. Okay. All right. Now what is asking? Determine IL of 0. IL of 0 is equal to how much you got, sir? 4 amperes. By the nature itself, inductor nature itself, we can find out. If previous value is 4 amperes, now present value is also 4 amperes. Why? Inductor will not oppose the sudden changes. Why are you calling it as sudden? Because I can say till 0 seconds the current is 4 amperes. That is, for a long time switch is closed and the current is 4 amperes. Now just after opening the switch also, that is at 0 plus instant also, 0 minus instant, it is 4 amperes. 0 plus instant also, it is 4 amperes. Alright. Now what is asking next question? V of 0 plus. Where is V? V is across 20 ohms. How the current is flowing? The current is flowing in this direction, sir. So positive polarity here, negative polarity here. So how much current is flowing? 4 amperes it is flowing. So you will be getting the voltage across 20 ohms will be, of course, minus polarity according to given polarity. Given polarities are plus and minus, but actual polarities are minus and plus. So you are going to get minus 80 volts. That is V of 0 plus. What is IL of t? IL of t can be taken as, that is according to time. As a time goes on, the inductor, whatever the energy which is stored in the inductor, when it is stored, when the 4 amperes current source is connected, when the switch is closed, 4 amperes current source is going to store the energy in the inductor in the form of magnetic field. Now when the switch is disconnected, inductor is going to discharge the energy through 20 ohms resistance. So the energy discharge will be as a function of time. For how long it will be existed, sir? Will it be existed for a long time? No, it will be existed for a short time. That's the reason why inductor and capacitors are called as temporary storage elements. Temporary storage elements are temporary sources. We can call it as temporary sources. Now IL of t can be taken as it as I naught into e power minus t by tau. What is I naught? Previous current. How much that? 4 amperes minus t by tau. What is tau? Only this part, sir. Be careful. Don't calculate tau as entire circuit time constant, sir. Where actually the inductor energy is discharging. Through which path the inductor energy is discharging, that part time constant you should calculate. So the inductor is releasing the energy through 20 ohms. Alright, so tau is equals to L by R. L is 2, R is 20. How much you will get? 1 by 10, 0.1 seconds. So tau is 0.1 or 1 by 10. You can call it as minus 10t amperes. E power minus t means exponentially decaying or not? If you draw a graph, it comes out like this. IL, this is IL of t, and this is time period. Now, at 0 seconds, if you put t equal to 0, how much? You'll get e power minus 0. 1, I naught will be 4 amperes. So it will decay like this. Within how much time? 10t seconds. Okay. So that could be the possible answers for this one. That could be the possible answers for this one. Okay. Did everybody got that one? Did everybody got that one? If you have any doubts, please ask me. Yes. Very good, Rahul. Umesh, 4 amperes. Very good. Umesh, 0 volts. 0 volts across what? We have 0 plus is 0 volts. No. 4 into e power minus 10t. Very good, Umesh. IL of 0 plus is also 4 amperes. Very good. Rajkumar Singh. 4 amperes minus 80 volts. 4 into e power. Very good, Rajkumar. Tarun Ravi. Very good. And Shreya is asking why we neglect 15 ohms for IL of 0 plus. Why? Because inductor has a closed path through 20 ohms and current enters at this node. Is there any chance of current flow through this branch? No. Why? Because switch is opened. So current cannot flow. You apply KCL at this point. 4 amperes is entering, 4 amperes is leaving. Don't expect the current flow in this branch. Why? Because 4 amperes is delivered by this current source and flows through this 15 ohms. Enters at this node. Is there any division of current in this direction? No. Then this entire 4 amperes will leave in this direction only to satisfy KCL. No current flow in this path. Is there any current flow? Single path. Current needs a 2 paths for flow, for enter and to leave. It cannot enter and it cannot come through only one path, sir. Okay. It needs a 2 paths for entering and for leaving. Alright, then if you get it, fine. What will be V of 0 minus? V of 0 minus is 0. Kanishta Rao, because the current is only flowing through 2 Henry's inductor. That is completely short circuited. Short circuited across any value of resistance. What will be the value? Short circuit means R is equal to 0. So definitely any value of current into 0 resistance will be 0. Across a short circuit, if you connect anything, it will be 0. Kanishta Rao, yes, very good. You are saying that. Okay, you are asking question and you are posting the answer also. Anyhow, very good. Let me take those comments here. Elango. Nitesh, which question answer you need? There is some net problem, so I can't able to see. My sincere request, my dear, is please look into the YouTube series after finishing this lecture because I am about to close this session. Rijvi, why you are negative? Why minus 80? Oh, minus 80. Why are you asking minus 80? Because in the question itself, the polarities are given as positive and negative at the top and bottom. But how the current is flowing? The current is flowing. The inductor is discharging the energy in this direction. Therefore, entering polarity for any current entering polarity will be positive for any passive element. So positive here, negative here. But what is the given polarity? Opposite. No, that's why I have taken minus 80. Sir, if you have any doubts, you can do another way also. You can do another way also. That is VL. Check VL. VL is equals to L into di by dt. L into di by dt. What is the L value? 2 henries. D by dt of IL of t. IL of t. What is IL of t? 4 into e power minus 10t. 4 into e power minus 10t. Check this one, differentiate this one, you will get it. 2 into 4 into minus 10 into e power differentiation e power minus 10t. How much you are going to get? 4 to say 8, 8 into 10 minus 80, minus 80 into e power minus 10t. Voltage across inductor also, that gives you minus 80. You can check like this. The voltage across inductor will be negative. Voltage across inductor will be is nothing but voltage across resistance or not. Both are connected in parallel or not. Both are connected in parallel. Whatever the voltage you will get across inductor, the same voltage is available across 20 ohms. Alright. Did everybody got that one? So that we can wind up here. Previous Nitesh, please, my sincere request. Okay, Alango, nice. Sunanda, White, Kanistar Rao, thank you, one and all. And you have a homework. You have a homework. Actually, this one is your homework. It's a simple single voltage source and two resistors of one inductor. You can do it. I think, okay. Chalo, bye. Take care. We'll see you tomorrow on at 5 o'clock. Done. Bye. Bye, everyone.